Hey there everybody, welcome back to more Pre-Calc 11. We're going to continue on with our trigonometry lesson, and really we're going to build on what we did last video, which was looking at special angles, special triangles. And so you'll recall that there's two kinds of special triangles that we're going to kind of expect you to have memorized. And that's a triangle that has a 45, 45, 90 degree angle, or a right angle triangle that is a 30, 60, 90 degree. And so the ratios of these, again, you should just be able to kind of come up with this on the spot. The ratio of a 45 to 45 triangle is a 1-to-1 ratio, because those sides are the same, and the hypotenuse will be root 2. And if you ever forget that, you can use Pythagoras to kind of figure that out. The ratio of the 30, 60, 90 triangle is a little more complicated. The shortest side, we'll call that 1. Then that ends up meaning that the hypotenuse is 2, and then the other side, the third side, is going to be the square root of 3. And again, if you kind of forget that, you could use Pythagoras to figure that out. So 1-to-1 to root 2, and 1-to-2 to root 3 for our two triangles. So we can use these to find exact values for trig ratios if the terminal or the reference angle of an angle is one of those, 30, 60, or 45. So imagine we've got this situation. We're going to find the sine of 150 degrees. So as a reminder, we know that this is my 0 point, so that's 0 degrees, and then there is 90, and then 180, 270, and then back again at 360. And so if I want to find the sine of 150 degrees, well, 150 degrees will be all the way through the first quadrant. I'll be over here in the second quadrant, 150 degrees, something like that. So that's my 150 degree angle from there to there, 150. The thing about 150 degrees is that it is going to have a reference angle that is right here between the x-axis and the terminal arm of the angle. And so the reference angle here, you can see if that's 150 and all the way to here is 180, then this will be 30 degrees. And so what that sets up is actually I've got a kind of a triangle here, this right angle triangle, and that's going to be my special 30, 60, 90 triangle. And remember that the reference angle, the ratio for the reference angle, is going to be related to the ratio for the angle itself, as we kind of saw last video. So let's figure this out. If this is a 30, 60, 90 triangle, then I know that my ratio of my sides, the shortest side would be 1, the hypotenuse is 2, and then the longer side is the square root of 3. And you always have to be careful here, because note that this 1, this side here, I would call that positive 1, because it's up going in the positive y direction. And the hypotenuse can't be positive or negative, but this other side here, this long side of the triangle on the bottom here, goes in the x direction, but it goes negative root 3. So I'd actually call that negative root 3. So if I want to find the sine of this angle here, well, sine is just opposite over hypotenuse, and so that's going to be the opposite, which is 1 over 2. And so the sine of 150 degrees should be a half, or 0.5. The cosine of 150 degrees is going to be adjacent over hypotenuse. Now the adjacent side here is negative square root of 3, and then the hypotenuse is 2. And so the cosine of 150 degrees will be negative root 3 over 2. It's important to notice that our trig ratios can be positive and can be negative, and we'll come up with a bit of a rule in a second here to figure out when that's going to happen. But note that the sine wasn't negative because this side was a positive 1 and the hypotenuse is positive 2, whereas the cosine was negative because this side of the triangle went in the negative x direction, and so that gave me my negative sign. Okay, let's do the other one here. Let's do it on the same grid. So now I'm going to look at 315 degrees. So 315 degrees is going to be all the way around here in the third quadrant. So I'm going to go all the way around to the third quadrant here, and maybe I'll end up something like this. So there's my 315 degrees. And if this is 315 degrees, it's really helpful to always find the reference angle, because the reference angle is going to kind of help ground us in what we're doing. Well, if this is 315 and the whole circle will be 360, then 360 minus 315 means this is a 45 degree angle right there. And that means that I can kind of create my other special triangle, my 45, 45, 90 triangle. And if that's a 45, 45, 90 triangle, then I know that the ratio of the sides is going to be 1 to 1 to root 2. But I want you to stop for a second and realize I've actually made a little mistake. It's not quite 1 to 1 to root 2. Those are the right numbers, but one of those numbers should be negative. And what you recognize is this side of the triangle here goes in the positive x direction, so that is positive 1. But this side of the triangle goes in the negative y direction, so this should be negative 1. Okay? And the hypotenuse is root 2. The hypotenuse is never going to be positive or negative, or it's just going to be positive, I should say. So the sine of 315, sine is opposite over hypotenuse, so that's going to equal negative 1 over the square root of 2. Now, at this point, if you got to here, that's great. You can leave it like this. But I do want to point out that we are later on going to learn about radicals, and technically leaving it like this is kind of a no-no. So I'm just going to fix it because I can't help myself because I'm a math teacher, and I'm just going to change it slightly by multiplying the top and bottom by the square root of 2. And so this ends up being negative root 2 over 2. If for right now you have your answer and you leave it like this, for right now that's fine. But what we'll learn later on is that we actually need to kind of modify that a little bit and change it around. Now in terms of the tan of the angle, where tan is going to be opposite over adjacent. So the opposite is negative 1 and the adjacent is positive 1. So I guess that's just going to be negative 1, and that's my tan of 315. So you can do this for any angle where it has a reference angle of 45, 30, or 60, because that's going to give you that special triangle, and then you can work out the ratio. So let's just think about what these ratios mean in the first place, because I think this is something that kind of gets like glossed over a certain amount when you're learning about it in grade 10 or whenever it is. So if I have a circle here, okay? So imagine I have a circle, and this is going to be a special circle called the unit circle. And the unit circle is special because it has a radius of 1. And so let's imagine that I've got some angle here on my unit circle. So I've got some angle theta. And you note that the radius here is 1. Okay? Now this will still be true for whatever circle we decide to use, but for the unit circle with a radius of 1, it simplifies things a little bit. And so imagine that at this point right here, this point in space, I could call that x, y. And there's kind of two ways for me to describe how to get to that point, right? If I wanted to give you directions from the origin and to tell you to get to that point, I could just give you the x and y coordinates, and you could walk a little bit in the x and walk a little bit in the y, and you'd end up there. Or I could tell you the angle, and I could tell you the length of the trajectory, and so you could get there that way as well. So let's look at that x, y breakdown. So if I go a certain amount in the x direction, and then turn and go a certain amount in the y direction right here, there's my x, and there's my y. And so if I'm looking for, say, the sine of theta, the sine of theta is going to equal the opposite over the hypotenuse, which in this case is r. So the opposite y over r. And r is just 1. So this is just going to become y. And so what I want you to recognize is the sine of the angle is really related to the y coordinate. The y coordinate is really going to tell you about the sine of that angle, whereas the cosine of theta is going to equal adjacent over hypotenuse. That's x over r, or in this case, since r is 1, just x. So the cosine is really telling you about the x coordinate. And the point is here, as you start here at 0, 0 and go around and around this circle, as you go around that circle, you could think about how are the x and the y coordinates changing as you go around. Well, in this first quadrant, for example, the x is always positive and the y is always positive. And so both sine and cosine will always give you positive ratios. But maybe that'll change once you move into the second or third or fourth quadrants. So just to finish this off here, the tangent, what is the tan of theta? Well, tan of theta is going to be opposite over adjacent, which is y over x which just is y over x. So the tangent is going to be that ratio of the two sides. And so you could see, for example, as you go around this circle, there's a certain maximum value you could get for your x-coordinate. Think about that. What is the biggest your x-coordinate could be as you go around a circle that has a radius of 1? And what is the biggest your y-coordinate could be? And what is the biggest your tangent could be? That gets a little funky. Okay, so let's kind of break this down and let's think about what we were just talking about. As we go around, if our sine of our angle is going to be equal to our y-coordinate, and the cosine of our angle is going to be equal to the x-coordinate, and the tangent is going to be the ratio of those two, we can come up with a general rule for when this is going to be positive and when it's going to be negative. Like we saw, all of the ratios are positive in the first quadrant. So I remember I've got quadrant 1 here. So quadrant 1, 2, 3, and 4. And all of the ratios, sine, cosine, and tan, will all be positive in the first quadrant. If I have an angle in the second quadrant, you can see that the y-coordinate of that angle is going to be positive, but the x-coordinate is going to be negative. And so what that means is the only ratio that's going to be positive in the second quadrant is sine. So they'll all be positive in the first quadrant. Sine will be positive in the second quadrant. As we keep going around, when we get into the third quadrant here, both my x and my y coordinates are going to be negative. That means sine is going to be negative and cosine is going to be negative, but remember, tangent is the ratio of those two. And a negative divided by a negative is a positive, which means tan is going to be positive in the third quadrant. And in the fourth quadrant, your y coordinate is negative, but your x coordinate is positive. So in the third quadrant, your cosine ratio is going to be positive. So they're all positive in the first, sine is positive in the second, tan is positive in the third, and cosine is positive in the fourth. And the way to remember this is the mnemonic: all students take calculus. And that's a little bit self-serving, but there you go. So they're all positive in the first, sine is positive in the second, tan is positive in the third, and calculus is positive in the fourth. So without using a calculator, determine if each ratio is positive or negative. The sine of 260 degrees, so the sine of 260 degrees would be, let's see, there's my 0, 90, 180, 270. So 260 degrees would be just short of that 270. And so I can see that's in the third quadrant, so that would be negative, because sine is only positive in the first and the second. The cosine of 315, well, there's my angle, there's 0, 90, 180, 270, 315 would be like over here somewhere. That's in the fourth quadrant. Cosine is positive in the fourth quadrant, so that would be positive. And then tan of 91, well, there's 0 and there's 90. So I know this angle is just past 90, means it's in the second quadrant, which means the tan will be negative because tan is only positive in the first and the third. So that's great for when we're in the quadrants, when we're in quadrant 1, 2, 3, 4. But we've kind of ignored 4 important points, which is what happens if we're exactly on the x-axis or exactly on the y-axis? What happens to our trig ratios when we're at 0, at 90, 180, 270, etc.? And so I'm going to go back to this unit circle idea, and let's think about this again. We said that for a given angle, right, for any given angle here, that the coordinates x and y, that my x coordinate is like this side of the triangle, my y coordinate is this side of the triangle. And so I want you to think about, let's try and do this visually, what happens if you start here and you kind of rotate around as you go around this circle. So starting in that starting position and rotating around the circle, what's going to happen to the value of the x coordinate? What's going to happen to the value of the y coordinate, right? Sine is going to be y over r. Cosine is going to be x over r, and tan is going to be y over x. And remember that the r value, in this case we could make it 1, but it could be any number. It's definitely going to be positive. So let's think about this. If I have this angle here, if it starts right at 0, 0, and it starts to rotate around, but starting right at 0, 0, the y-coordinate, when it's in that starting position, the y-coordinate is going to be 0. So the sine of 0 will be 0. As I start to rotate around, as it gets around to this point at 90 degrees, the y-coordinate is now as far as it can be from the origin. And that means if the radius is 1, then it's going to be located at a point 1, which means the sine of 90 is 1. As you go from 90 degrees and you keep rotating around, and eventually you make it back to 180, the y-coordinate when you're at 180 is back to 0. And then keep on rotating around down to 270, your y-coordinate will be -1. And there's a definite pattern here that I want you to notice. We go from 0 to 1 to 0 to -1. If you kept going around the circle, that pattern would continue. It would go back to 0, then up to 1, then down to 0, then down to -1, and around and around. And so what about the cosine? Well, if I'm in that starting position at 0, 0, then the x-coordinate, when I'm at 0 degrees, the x-coordinate is going to be at a maximum. The x-coordinate is going to be equal to the length of the radial arm there, and so that is going to be a value of 1. As I rotate around to 90 degrees, now all of a sudden my x-coordinate is going to 0. When I point straight up, my x-coordinate is 0, so the cosine of 90 is 0. As I then rotate around to 180 degrees, now the x-coordinate is going to be maximum negative, which means it's going to be -1. And if I keep rotating around to 270, the x-coordinate again is going to be 0. And so, yeah, there's a definite pattern here as well. And there's a relationship between sine and cosine, which you might start to notice. They have the same pattern. It's like they're just slightly out of sync by 90 degrees. For tan, it gets a little bit interesting. So remember that tan is the ratio of the y to the x. So it's going to be the y value divided by the x value. When we start off at our 0 position, at an angle of 0, y is going to be 0, and x is going to be 1. So this is going to be like 0 over 1, which is just 0, because 0 divided by anything is still 0. But something funny is going to happen as we rotate around to 90 degrees. As we climb up to that 90 degree point, the y value is increasing and the x value is decreasing. And when we're actually pointing 90 degrees straight up, the y value is 1 and the x value is 0. And 1 divided by 0 is not 0. 1 divided by 0 is undefined. You can't do that. So that's basically going to go off to infinity and never get there, which means it's undefined. Okay, it's not a number that we're going to reach. When we keep going around, so we go from there and we go back to 180, now the ratio is y divided by x. So y again will be 0 and x will be 1, which means now we're back to 0. As we keep rotating around to 270 degrees, we get back to this situation where our y value is 1, but our x value is, well, it's actually -1, and our x value is 0, so this again becomes undefined. We're actually going off towards -infinity. Okay, so looking at this chart, there's some definite patterns there to help you out. I would really highly recommend you not try to memorize this. Memorizing this is not going to be fun, and it's too easy to mix up one little thing. What I do want you to remember is that the sine of theta really depends on the y coordinate, and the cosine depends on the x coordinate. And if you remember that, then as you go around, you can kind of figure out, oh, here x is 1, here x is 0, and so on. The tangent's a little trickier, where you're going to have to remember that that is going to be the ratio of y over x. But again, if you can do that, then you can work out what it's going to be. And so the expectation would be that you would know, without a calculator or anything, what the sine of 180 is, or the tan of 270, or the cosine of 360 degrees. And those are things you should be able to come up with. Okay, that is it for special angles.